Hello, I'm James. I'm the Vice President of Bioprocessing and Applications at Microfluidx, and my background is in process development and translation, and today I'm going to talk to you about our technology. The Cyto engine is our core technology. We built the Cyto engine because we believe that cell therapies are a pain to translate, to manufacture, and to get to the patient, not to mention they're extremely expensive. To address these issues, the Cyto engine blends three different technologies. Firstly, the most precise and scalable bioprocessing platform out there. We'll get back to you more on that in a minute. Secondly, integration of the best online sensors that are out there. We're talking pH, dissolved oxygen, 11 different metabolites, but also online imaging with cell density and cell morphology. Thirdly, the most user-friendly data visualization, management, and analytics tools available. Together, these three elements can accelerate cell research, process development, and drastically reduce the cost of cell therapy manufacturing. This is our research bioreactor Explorium. This can be used with both suspension and adherent cells. For adherent cells, we've got a surface culture of 12 centimeters squared. For suspension cells, we can have between 0.5 ml and 12 ml. Once the cells are seeded, we can run a range of different processes from cell activation, transduction, transfection, and differentiation. You can also do in-process washing and concentration within the bioreactor. The fluid is exchanged through our perfusion system, which also allows us to be able to maintain the cells in an optimum condition. We can agitate the cells and we can actively gas the chamber, which allows us to be able to maximize the KLA that the cells are exposed to. The result of this are truly excellent cell process efficiencies, repeatability, and cell health. Let me show you some of those results now. An example is viral transduction of primary T cells. With our bioreactor, we're able to reach up to 5 times higher transduction efficiencies, even compared to well plates, which are actually known for having higher than average transduction efficiencies. That translates roughly into a saving of 10 times in viral vector consumption. What's even more important, in my opinion, is that the transduced population was 2 times more homogeneous in our bioreactor. That means a shorter process, less cost of reagent, and a more homogeneous product. And this is not just with viral transduction. For example, across a full T-cell process, we see high process efficiencies in our bioreactors for every single process step from cell selection to expansion to harvest. Another example is expansion of mesenchymal stem cells. Here we showed that MSCs grow twice as fast in our bioreactor compared to the standard research-grade cell culture vessel. Analysis of the phenotype using the standard ISCT panel showed that we were able to maintain the putative stemness markers such as CD90. The last example is around repeatability. Repeatability with cells has always been a sensitive topic, but thanks to the extremely fine control of the microenvironment in our Microfluidx, repeatability in the MFX bioreactors is outstanding, whether we're talking about forward expansion, transduction efficiency, or cell viability at the end of the process. So, cells seem to like our bioreactor, and to us this is the most important factor. But what about automation? Explorium is our fully automated research and process development system. Really, it's a DOE machine on steroids. Simply connect your reagents and our bioreactors via our patent-pending aseptic connection system. Load your design of experiments and click play. The system can take up to 30 research bioreactors with 0.5 to 12 ml capacity. The system will automatically feed the sequence of the right reagents to the right bioreactor. As an option, you can choose to have an inline metabolite analyzer, which will measure up to 11 metabolites. pH can be automatically controlled via our active gassing system, and the user can also choose several agitation modes for each bioreactor. When you finish your experiment, all your data collected during the process is available in a single file, which can be analyzed on multiple software platforms. Now we have shown that we have a cell-friendly bioreactor that can be automated, so the next question is about scale. Microfluidix in general is not known for large-scale production, but we are proud to present the first bioreactor that is in Microfluidix that is capable of making patient doses. The way we scale is similar to transistors in electronics that make up a board. The research bioreactor is our transistor. By parallelizing dozens of these into a larger array, we ensure that we don't change the cell's environment. Media access, shear stress, and gassing, everything remains the same from the cell's point of view. This way, we retain the advantages of Microfluidx and remove the need for lengthy process development that often occurs between preclinical and clinical stages. We have developed two versions of this. The first size can hold from 10 to 200 ml, and the second one can hold from 200 to 400 ml. I'm currently holding the larger version of this, which can hold about 5 billion patient cells. We have also developed a fully automated, fully closed system for this. It includes ambient and refrigerated reagents, GMP connectors, single movement tubing connection, online pH, dissolved oxygen and imaging systems. Supernatant and cell sampling are also available during the process. Whether you have adherent or suspension cells, this device will run any reagent sequence in a fully closed and automated way. We're planning to launch this device in GMP standard by 2024. We hope you've enjoyed our presentations and learning more about Microfluidx's technologies.